Hello and welcome to Fluid Power Systems. When we connect or operate a fluid power system, we use a lot of different valves and measuring devices. Such a system is the hydraulic system shown, where the main unit or device is the actuator. The actuator is the output of the system. This actuator, for example, is responsible to do the work on a workpiece. In a fluid power system, this actuator is called a cylinder. Learning fluid power systems can be a challenging experience sometimes. My goal is to help you learn in an easy way, in a practical approach, so that you can get started operating, reading blueprints, and troubleshooting fluid power systems in no time. This course is packed with exercises and activities that challenge you and help you grow as a systems engineer or technician. I hope you will enjoy it and get something worthwhile from it. My name is Omar Tentawi and I'm your instructor. While you certainly can watch these videos in any order, I do recommend starting at the first lecture and moving through one at a time because the lectures do build on each other. As you go through the course, please feel free to participate and ask questions. Your inputs are more than welcome. A hydraulic power system, like the one shown, can be divided into three units: the power unit, the control unit, and the actuator unit. The working fluid or oil circulates from the power unit to the control unit to the actuator unit through the supply line. Then from the cylinder back to the control unit and finally to the power unit through the return line. This is a basic hydraulic system where each unit can be divided into three subunits. So the power unit contains a pump unit. It takes the oil from the suction line and supply the system with the pressurized oil. The amount of oil can be adjustable. A pressure protection unit protects the system from the high buildup pressure. This can be adjusted. A tank unit, it contains the working fluid and it cools, measures, filters the oil and smooths the oil flow into a laminar flow. The control unit, we have direction control or DCV. It controls the cylinder direction of movement, extending or retracting. This can be set mechanically, such as the mechanical hand lever, or electrically or hydraulically. A flow control unit controls the speed of the cylinder. This can be adjusted. And the sequence control unit controls the sequence of movements of multiple cylinders. Here we have only one cylinder, so this unit is not used. Now for the linear actuator, we have the cylinder head unit. Is designed and used to do the work motion on the workpiece, and it's mounted on a threaded rod or a tie rod or an eye rod. A deceleration unit decelerate the extension or retraction speed to a soft stop. This can be adjusted. And a piston rod unit. There's types of them. There is the piston double rod, piston rodless, with no piston, only rod. What we have here is piston rod unit. Now, let us look at what these hydraulic components looks from inside and understand how they work. At first, let us identify the components. Power unit have a pump, this type called a gear pump, a pressure protection unit. Here we have only a relief valve, and a tank unit. Moving to the control unit, we have a direction control valve, DCV, a flow control valve, FCV, a combination of a check valve, which is also called one-way valve, and a needle valve to make one flow control valve, or FCV. For the linear actuator, we have the cylinder head unit mounted on a threaded rod, a deceleration unit. This one decelerates the retraction just before it comes to stop. and it's called a retraction cushion. And the other one decelerate the extension just before it comes to stop. And the piston rod unit, the piston is a circular cylindrical shape, and the rod is the long rounded bar. To understand how these components work, let us examine the machine operation. At the beginning, the machine is on and is set to be in home or neutral position, where no operation or work is done. The pump shaft is attached mechanically or coupled to the motor shaft, causing the gear on the right side to rotate counterclockwise, which will cause the meshing gear to rotate clockwise. This meshing action will cause or create a vacuum on the inlet side of the pump and high pressure on the outlet side. This cycle causes an increase of volume on the inlet, a suction, and a decrease of volume on the outlet, pumping. This pumping cycle happens many times per minute. So a suction on the inlet and a pumping on the outlet. The high pressure oil will flow and always to the pressure port of the DCV. Inside this valve is a 2 piston rod units, one on each side, and 1 piston double rod unit in the middle. So totally we have 3 piston rod units, means 3 positions the cylinder can have. The 3 units are attached together as a single component called a plunger. Shifting the plunger all the way to the left or all the way to the right is done by moving the handle forward or backward. If the handle is not moved or in a neutral, as it shows now, the plunger is shifted to the center by the 2 springs on the ends. In this case, the pressure port is blocked. The pumping cycle will continue and the pressure will continue to build up. Once it reaches the maximum pressure, it will open the normally closed relief valve by pushing the poppet off its seat, releasing the high pressure oil back to tank. This pressure to open setting on the relief valve can be adjusted manually and is called the system pressure. The system pressure can be set only when the machine is in a neutral position or when the flow is routed directly to the relief valve. If the hand lever is pushed forward, as we saw now, the plunger will shift to the extend position. In this case, the pressure port and the actuator port are connected, P to A. The back port from the actuator and the tank port are connected, B to T. The high pressure oil will flow to the speed control valve, which will be forced to go through the restricted passage opening, causing the pumped amount of oil to take a longer time to pass through. And that slows down the cylinder extension speed. Connecting the flow control valve in this way to control or restrict the flow in to the actuator is called a mirror in connection type. An easy way to identify the connection type is by looking at the check valve. If the poppet is pointing into the cylinder, then this is a mirror in connection type. Now the cylinder receives the flow in at the piston side, which is also called the cap inside. This flow must build high enough pressure on the piston to push the load up. But to be honest, this happens instantly since the oil is a liquid and liquids are incompressible. But since this is an animation and for only explanation purposes, there's some delay time. A pressure is just an exertion of a continuous force upon a surface. This force is directly related to the piston surface area. The larger the piston, the more force can be exerted. The oil on the rod side will flow out to the check valve unrestricted path, pushing the poppet off its seat at a minimum pressure, flowing through the check valve and back to the direction control valve, then back to tank. When the hand lever is manually pulled all the way back, the plunger is shifted to the retract position, where the P port and the B port are connected, P to B, and the A port and the T port are connected, A to T. The high pressure oil will flow to the needle valve and will be forced to go through the restricted passage opening, causing the pumped amount of oil to take a longer time to pass through, and that slows down the cylinder retraction speed. The overall connection of the flow control valve is a mirror in connection type, where the flow in to the actuator is restricted. The cylinder receives the flow in at the rod end side. This flow will build a minimum or low pressure on the rod end area to aid the load down. The oil on the cap inside will flow out through the check valve, DCV, and finally back to tank. In this activity, you'll be cutting some components on a page, building a machine on another page, and creating a blueprint. So let's look at the activity. On this page, you'll need to cut out these components. There's some components I've added, like these two gauges, two check valves, like in addition of the other check valves, and I've added also this gauge. It reads the flow rate, called a flow meter. The oil comes in on the inlet port. It will go through the annular area and push the piston to a certain level. And once the piston becomes stable at that level, read the marked line, which will be the flow rate. Build the machine on this slide. There are the extra components we just talked about, so I want you to try to figure out where to add them. On this page, you need to draw the schematic symbol for each component. So starting from the tank symbol looks like that. Inside the tank there is the filter. The symbol is the diamond shape. Inside the diamond shape there's the dashed line. And it has the inlet and the outlet port, in and out. So when the oil comes from the in to the outlet port of the filter, will be filtered, indicated by the dashed line. And the filter will go to the pump. The pump is a rotary pump, so indicated by the circle. And a solid arrow pointed on the outlet, like solid head arrow pointed on the outlet with a pump, and that's indicating the pumping action that we've talked about before. The pump is coupled with the electric motor, showing by those two parallel lines. Now the electric motor is a rotary actuator, so a circle inside it. There's M, indicate it's a motor. So now the pump will pump the oil to the system. There's a T connection. If the oil or the fluid reaches the maximum pressure, then it will go through the relief valve. Most of the pressure valves are indicated by a block, like a relief valve. This is the in. That's the out of the block. Relief valve is a normally closed valve. It has a spring. The spring force is what closing the poppet or the valve, and this spring force can be adjusted by the screw can be adjusted manually. So it's a normally closed. That means the inlet is not connected to the outlet. So we'll draw like an arrow at the bottom of the block and a dashed line from the middle of the block to the input or the inlet port. If the pressure reaches a maximum at the inlet port of the relief valve, it will push the arrow up to the middle, connecting the inlet to the outlet. The outlet will take the high pressure oil, dump it back to the tank. If the oil did not reach the maximum pressure, then we have a flow all the way to the DCV, the direction control valve. The direction control valve, it has 3 positions. If the handle is pushed all the way forward, then I'll end up with the extend position. If the handle is pushed all the way backward or back, pulled all the way back, I'll end up with the retract position. If it's in neutral, I'll end up with the P port blocked. So I'll end up with a blocked position. If you looked at it, you'll see that the A port is also blocked, the B port is also blocked, and the T port. So to extend, I'll pull the handle forward and I'll have P to A connection, B to T. If I pull it all the way back, I'll have P to B connection. The cylinder has to retract, and A to T. When the handle is in neutral, the spring force at the ends will take over and push the plunger to the center, so I'll end up with a blocked, which is also called a hold position. Alright, so at the extend position, for example, the oil will flow to the flow control valve and will be forced to go through this restricted passage opening. This passage opening can be adjusted. So that's the symbol of this component. At the bottom right here we have a check valve. That's the symbol of the check valve. And these 2 components are inside one device. So I'll draw a dashed dot line indicated that these 2 are inside one device. So again, the oil will flow to the needle valve component. From the needle valve will go to the cylinder. The cylinder has these 2 ports, A and B. Now the cylinder, which is the actuator unit, has 3 subunits. The first one is the head unit. That's the symbol of the head unit, like that, a bar, and then there's 2 brackets. On the opposite direction means it's detachable. And it also has the cushion or the deceleration unit and the piston rod unit. So I'm going to draw the piston rod unit. I'm going to start with that piston rod unit. On the rod we have the head unit attached. On the piston we'll draw an arrow like that, indicated that there is 2 cushions for deceleration unit. One to decelerate the retraction when it comes, just before it comes to stop, and one for the extension. So if I'm trying to extend the cylinder, then the piston needs to go up and the oil on the other side will start to flow out. We'll come right here. We'll pick the least resistance path, so it's going to pick the check valve. That's why it's called one-way valve. It will be easy to push the poppet off its seat at very low pressure rather than going through the restricted path. So When I retract, we'll go through the check valve to the T port right here. If I'm trying to retract the cylinder, then the oil will be forced to go through the needle valve. Like we'll be forced to go through this restricted passage opening, which can be adjusted. Now these two components are separated. It's not inside one body or device, so I'll leave it like that. And the oil will come back from the cylinder through the check valve back to the DCV and then back to the tank. When it goes back to tank, this is where I'm going to start adding the extra components. The first component I will add, which you'll see it on most of the systems, the flow rate gauge or the flow meter. It reads the flow rate. It looks like a baseball shape or a tennis ball shape. This is the N, and that's the out, and cannot be switched. It cannot be switched. So the other components we have is two check valves. The first check valve I'll add it right here inside the tank where the filter is. So I'll add it with a parallel, like in parallel with the filter. In case of the filter got clogged, then I have a check valve, an alternative path. And like the oil only requires very low pressure to open that check valve, but much less pressure to go through the filter. I'll also add another check valve immediately at the outlet port of the pump. Is because when I turn off the pump on the outlet port, I always have high pressure. Once I turn off the pump, it will reverse the pump back. Some of them, they get damaged. And it goes back to the tanks. So to protect that, I'll add a check valve. It's a one-way valve. Other two components we have the gauges. So I'll add them right here on the inlet and outlet ports of the cylinder. One on the cap inside. This will be gauge A, and the other one gauge B. When you do the lab, you'll see that there is a gauge already installed right here, and this is gauge S. It reads the system pressure. It's for you when you set up the relief valve pressure, you need to read how much is the pressure on the gauge system.